So we solve one more example related to measures of variation. And as I said that we will solve one simple example. Again, let's say I take the same data which I took before, x is 4, 15, 3, 10, 15, and 9. And I take y is uh, 9, 17, 8, 11, 14, 8, 11, 14, and 12. So sum of x is 56, sum of y is 71, and now what we want to calculate, we want to calculate coefficient of correlation. So the formula for coefficient of correlation is n times sum of xy minus sum of x times sum of y divided by n times sum of x square minus sum of x whole square times n sum of y square minus sum of y whole square. So I have almost everything. I just need sum of xy. So xy is 36, 255, 24, 1110, and 2110, 108. Sum of xy, we have already calculated it in the previous example as well, and I need x square, which is 4, 225, 900, 225, 81. So sum of x square is 656, and I need sum of y square as well, which is extra, which was not in the previous example. 64, 1 to 1, 196, and 144. So if I take its sum, it will become 81 plus 289 plus 64 plus 121 plus 196 plus 144, 895. So sum of y square is 895. I simply substitute all these values into this formula. R square, n is 6, number of values are 6, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So 6 times sum of x, y, 743 minus sum of x, 56, sum of y, 71 over square root of this. Again, n is 6, sum of x square is 656 minus sum of x whole square, 56 whole square, and then again n is 6, sum of y square is 895 minus sum of y whole square. So if I solve this, 743 times 6 is 4458 minus 56 times 71, which is 3976 divided by this which is 656 times 6 equals to this minus 56 square, and the answer is 800. This one is 800, and similarly 6 times 895 equals to this minus 71 square. So the answer is 329. So 4458 minus 3976, which is 482 over 800 times 329 equals to 263,000. And if I take its square root, it is 513.03. So our R is 482 divided by 513.03.93. R is 0.93, and if I take its square, if I take its square, it is 0.88. So correlation, which is R, is 0.93, and coefficient of determination, which is R square, is 0.88. From here we can interpret that they are strongly correlated with each other. R is positive and very high, so they are almost perfectly correlated. Both are increasing, and the change in Y, independent variable, 88% change in Y is because of X. This is 0.88, which is 88%. And now we can calculate standard error of estimate. So the formula for standard error of estimate is, I move to the next slide, but it would be difficult for me to see what was the value. So I try to take the picture, and then I can take the help of that picture so that I would be able to write down the values. So I want to calculate standard error of estimate. In the PPT, the formula for standard error of estimate was different. That was difficult to calculate. If I use this formula, and it is a bit easy for me to apply b times sum of xy and over n minus 2. Now, what is a and b? If you can recall, a was something 0.6.12 and b was 0.60. Regression coefficients, like in the previous example where I was using regression equation, I calculated this a and b. These a, b's, this a and this b belongs to regression coefficient. Sum of x square, we know sum of x square is 656. Sum of x is 56. Sum of xy is 743. We can substitute the values into syx. Sum of x square is 656 minus a, we calculated in the previous example because the example was same. So that is why I am using the same results. And sum of x is 56 plus b is 0.6 times sum of xy is 743 divided by n minus 2. Now we solve this and we get 656 minus 6.12 times 56 equals to this. I think we made some mistake. 656 minus 6.12 times 56 equals to this, and plus it can be like this: 6.12 times 56, which is 342, and I have this one, 656 minus 342.72 plus 0.6 times 743, which is 445.8 over 4. And if we solve this, 656 minus 342.7 plus 445.8 equals to this, divided by 4 equals to this, and its square root is 13.77. So that is standard error of estimate. This is how we calculate standard error of estimate. I just repeat it once again. That is the formula for standard error of estimate. These a and b we calculated through this equation. A plus bx, we apply sum of y, n times a plus b sum of x. Then we apply sum of x, it becomes sum of xy, a sum of x plus b sum of x square. We substitute the values into this equation. We substitute sum of y, n, sum of x, sum of xy, sum of x, sum of x square, and then we solve these two equations for a and b. We substitute these a and b here into this formula, a and b, and we substitute rest of the things, and then we calculate SYX, standard error of estimate, and it tells us that how much there is variation among the values around the line. 13% values are, so that is it.